Yo, what up? Alright, here we go again. Back again. Another one of these things, huh? Y'all thought I quit. Y'all thought I quit. Y'all thought it was over. Not over. Okay, what's going on, everybody? Welcome back in to the stream. Hope you're having a good day today. All right, Keel. I think we're good. All right, cool. Um, Come on, I want to hide this. Really? How do I... Okay. There we go. All right, cool. Let's go ahead and get this show on the road. All right, yo. to go over here. Very cool. Cool. All right, let's solve some of these practice problems. Okay. Struggling here, boys. Okay. Okay. What's going on, everybody? Welcome in. Hope you're having a wonderful day today. Or me back. Hey, what's up, Tim? Welcome back. Appreciate you being here, Mr. Tim. Okay, we're on number 11. Cool. Oh, we're on 10. Okay, we're on 10. Okay, here we go. We're back in C Programming, a Modern Approach, second edition. Going to be going over these post-chapter practice problems. Getting some practice with them here. Let me go ahead and move over the chat. Put it there. Okay. Cool. Let's go ahead and get into this one. Okay, we're going to modify programming project 8 from chapter 5 so that departure times are stored in an array and the arrival times are stored in a second array. The times are integers representing the number of minutes since midnight. The program will use a loop to search the array of departure times for the one closest to the time entered by the user. Okay. Okay, so what did I do here? I have absolute value function that I made in my main function here. So the departure times are stored in an array. And arrival times are stored in a second array. Arrival times are stored in a second array. Okay, so we ask them to enter a 24-hour time. Then we compute the time into minutes. And then we have 8, 9. These are the different times. Okay, we set them here. Okay, so let's go back up to chapter 5, I guess, programming project 8. Okay, here we go. So this is where we're going to store arrival times and departure times, okay. Okay, so we'll have int departure times equals to is an array, right? And inside of here, wait, hold on. Okay, so we need to keep these times. These are the departure times. Okay, so we need to make arrival times then. So this will be 10:16 a.m. (10:16 a.m.), 11:52 a.m., 1:31 p.m., 3 p.m., 4:08, 5:55, 9:20, 11:58, okay. So then we're going to take 10:16 a.m., 11:52 a.m., 1:31, 3 p.m., okay, and this is 10:16. 11:52. 1:31. 3 p.m. So 3 p.m. I'll do a 24-hour time. Yeah, 3 p.m. 00. 08. This is 4. 5:55. 9:20. And 11:58. Hey, thanks, Alan. Thanks so much for the sub on YouTube. Appreciate you being here. Welcome to the channel here, my man. You are awesome. Let me okay. So that takes care of those. So then let's go ahead and do int departures size 1, 2, 3, 4, 5, 6, 7, 8. I'm going to grab all of these. Paste them in here. Oh, so that's arrivals. Okay, and then we're going to have int departures size 8, which will be an array of the departure times. Right? So now what we're going to do so we're going to say nearest. So we'll say int nearest is equal to nearest departure index is equal to 0. We're going to say for int I equals to 0, I less than 8, I plus plus. We're going to then we're going to do this evaluation here, right? So if the absolute value of what, right? So this would be the departures index I less than the time of minutes is less than the absolute value of this. So we're going to say if it's less than we need to set it to something, right? Initially. So I guess the nearest departure would be 0. So this would be, now we would just want to just do this evaluation, right? So this will just automatically find the time that's in between without going over the next departure time, right? So let's go back to our program here, or our problem. Seven, 8. Representing the number of minutes since midnight. This program uses a loop to search the array of times for the one closest to the time entered by the user. Okay, so the nearest departure time. Okay, so what we're going to do is just do departure less than here. I guess we'll set it to 0. We'll loop from So we'll say nearest index is going to be, or we'll say minimum. Okay, so I'm going to want to take the nearest in the index for the departure. We have the departures index I minus the time in minutes. This will give us the basically the total difference between the departure time and the time in minutes that it is currently that the user enters. And so then what we're going to say is if this value is less than the value we calculate here, we're going to set the index to that value, I guess. We want that departure time, so I guess we'll say int min time is equal to 0, or is equal to, this would need to be blank. So I guess we could set it first, right? So what if we set min time? Well, no, I don't think we want to set it to 0 or to one of the values at first, because I think we're trying to we need this to be a large value, right? You can only have, I guess, the amount of minutes that it would be in a day, right? Which let's calculator. Let's see here. We got 60 minutes in an hour. That's 24 hours. Okay, so 1440 minutes in a day. So that's the amount of, that's the maximum minute difference that you can have. Is that correct? Yeah, I think so, right? Okay, so we'll say this is going to be 1440. So minimum time. So then we're going to say this is going to be, we'll say int temp is equal to here. We'll get rid of this. We'll say if temp is less than the min time, then temp or min time is equal to temp. And then what we'll do is also set the nearest departure index equal to I. So then I think we can get rid of all this junk here. Okay, so let's see here. Now is digit in an octal constant. Uh, 10. Yeah. Oh, I don't have my print statement. Shoot. So closest departure time is oh, interesting. So we would need to do this many minutes. Okay, so we have that many minutes divided by 24 hours would give us the amount of hours, right? The remainder is left over as minutes. Right, so if we do printf, closest departure time is I'm going to put into, we'll say here is going to be a integer, right? And we're going to do another integer arriving at, I guess we'll do 2 faces of field width, and then we'll do the same, my bad. I guess we'll do the same format over here. But I don't really have the, well, with 24-hour time, I guess we don't need the AM, PM, right? Yeah. So what we're going to do is insert into here. So this first value is going to be the amount of, so it's going to be departure time index of a nearest deep index. So departures index of nearest departure index, and then this is going to be divided by 24. And then for the second one is going to be this value, but modded by 24. And I think it's going to be the same thing for the other two, but with the arrivals, rather. Hey, Siraj, how's it going? Hey, Eddie Bowles. No, I'm not a student. I guess I'm a student of my own, right? I didn't learn it on my own here, but I work. I'm 26. I have a degree in human bio and a minor in chemistry, and I graduated back in 2021. I work as a chemist for a biotech company. Been teaching myself how to code for about 1.5 years now, after my 9-to-5 job, which has been fun, but tiring. So we're going to do, this is going to be arrivals. Let's see what happens. I thought I already erased that. What the heck just happened? Uh, 10 a.m. Closest departure time is 50. Uh-oh. Minutes. Oh, we're in minutes. Right. So we have to do times 24 over 1440. Right? I can't need it. Wait. I need a piece of paper. Need a piece of paper. Let me see here. We're in whole minutes right now. And we just need to go hour per minute to get to hours, right? So we just have to divide actually this value by 60 minutes. for the first one. And then (10 a.m., 11:52). So I don't know if that'll do it either. 10 close to departure time is 21:09, 23:22. Hey, Overdue, how's it going? Welcome back in, my guy. Okay, so we're looping, generating the time in minutes. If temp is less than min time, if the temp value that we're generating here is less than the minimum time so far, nine. I'm getting 9. Where is that from? Amount of minutes. What do you guys think? Okay, so we have enter 24-hour time, 10 a.m. Closest time is 21:09, 23:22. No, I think it would be mod 60 probably, because we're trying to mod the amount of whole hours out from minutes. (23:58), 21:45. (9:45). 58 right there. But this is 10 a.m. Okay, so we have a bug here slightly, right? We need to handle if the 24-hour time that should be a long time away, right? This time 21:45, 9:45 p.m. Right, yeah, it's close to 10. Okay, so we have hours times 60 plus minutes gives us total time in minutes. Yeah. And then we make our own time here. We add them to the arrays. We take the difference between the departure and the time in minutes. So 10 a.m. 10 If I do 2300, closest time is 2145. What if I do like 1 a.m.? No, it's always hitting that. Okay, so it's just... Oh, all of our values are less than min time. So it might be happening with our overriding here. So so if temp, the value we're generating here, so departures index I, which is going to be 8 a.m. is less than the minimum time. So this is 1440 because that's how many minutes are in a day. The minimum time is minutes since midnight. So I think something is, the loop is continually let me go into here and print F. We'll say we'll put the temp here. We'll say temp. And we'll go backslash in. Temp 120 17. So it finds 17. It only ran twice, right? Or it only went into this twice. We only hit this print statement twice because 10 a.m. matches to the 9:43 a.m. departure time, right? That's the closest departure time to 10 a.m. And so that's why it only ran twice. It's 17 minutes away, which is perfect. That's right. So our closest departure time is, this is printing out wrong. Min time equals to temp. So I guess let's go like this. Let's print out min time %d, and we'll put into here the min time. Let's also print f the nearest departure index. And then we'll put in the nearest departure index, I guess. And let's see how this looks. (10 a.m.) So yeah, it's looping all the way to the end, and the minimum time is 7:05, which is not true because, oh, I got a bug. That's why. Brackets, gotta contain that if statement, genius. Come on. Yes! Let's go. All right. A little print debugging for the win, boys. Print debug for the win. Let's get a like up for that, huh? Let's get a like up for that. Cool. All right. That handles that guy. All right. That one's done. Number 10 is done. So now we get the nearest departure time to the time we put in. Let's try like 13:52. Closest departure time is, okay, so that's also, well, oh, and we need to do 2 decimals of precision. Let's do 13:52. 14. Yep, it's right there. It's really close. Yes. Let's go, boys. All right, feels good. Moving on to number 11. Okay, number 11 from Chapter 8, C Programming Modern Approach, 2nd edition by K.N. King. If you're enjoying the stream so far, go get a like. Give it a like. It's your boy out here losing his hair. Bro, no, bald. Leave a like for the bald. All right. Let's keep pushing. The winds of change. Hey, what's up, Tim? As a slow W print debugging. Yes, let's go. Purple. Purple piece. What's up, Frogstud? Welcome in. Hey, Luis from Mexico. Awesome. What's going on? Viva la Mexico. Welcome in. Okay, let's keep pushing. Number 11. Modify programming project 4 from chapter 7 so the program labels its output. Enter phone number in numeric form this. So that the program labels its output. The program will need to store the phone number either as in its original form or as in numeric form in an array of characters until it can be printed. You may assume that the phone number is no more than 15 characters long. Okay, let's go grab this guy. Project 4 from chapter 7. I hate when it has us go back and do these, like, revisit old problems. It's like, oh, just come on. My dad was balding by 25, so I'm right in line with him here. But he was balding worse than I am. We on that finasteride and minoxidil. We got that on deck. We've been taking that since we were like 19. We knew it was coming, boys. We knew this day was coming. Yeah, real dev maxing, bald maxing. Okay. So we need to modify this program. So we say enter a phone number. And then we get the char. And then we return. Okay. And we just print out the number. Okay, so we'd have to now have it with a label. So it wants us to just store it in an array. Okay, got you. Okay, cool. So we'll do this. Enter a phone number. 65 to 67 is a 2. Oh, it just wants us to use these characters or whatever. Oh, 1 through 9. From like an old phone pad. Okay, got you. So we're gonna need an array right off the bat. So let's do a int chars or int digits, and we'll have this be 15 characters long. So we'll say while get char c, we're going to we're going to insert the value into digits index of so we're going to need to set an I value. So int I equals to 0. So we're going to say if I is greater than 15, we're going to print f and say phone number overflow, and that'll handle that, and then we'll break. I guess we'll return 1. There's an error, right? So, right, we'll just catch this, make a little check here. Now what we'll do is we can keep these characters into our array. So what we'll do is we'll just say digits index of I is equal to 2. And then we'll copy this. This will be uh, 3, 4, 5, 6, 7, 8, and 9. So I guess we're gonna have to I could use a for loop, I guess, but if we have to do it 15 times, get char. But this will go until you go empty. So I'm not sure like what would be the more preferred way, right? I guess they could enter a phone number that's short in this case, where if you have a for loop that loops 15 times, you loop 15 times. So this one just goes until all the characters are absorbed in the standard out. Or standard in, sorry. So once this happens, I'm going to, no matter what happens, we're going to do I++ at the end of this if else chain. And then that'll do it, I guess. And then we're going to do some print statements, right? So in numeric form, so we're going to say in numeric form, so I guess I could change these, make these a little bit more clear right now, because right now I'm just overriding high ints for low ints because these high ints are ASCII characters. So what I guess I could do is do like if C is equal to literal quotes, capital A, capital B, capital C, then we're doing this, right? Something like that, but I mean, because the get char is only going to get one char at a time, though, so it won't ever actually get values that are double digit, unless it is a character. So in numeric form, we're going to print this, and then we're going to say for int I equals to 0, I less than 15. Or what could I say, maybe? Let's do this. While put char, do put char. We'll do put char. And we're going to do Let me look up put char again. Put char and see int character that we're going to be putting to the screen. Okay, just help it. I guess we'll say I is equal to 0. I get set back to 0 here. Do put char for digits, index of I, while digits maybe not. Maybe this isn't the best way to do it. It says char array. Oh, until an array of characters. Char digits. Get char. How should I do this part? So I could say, you're gonna print a number. That's assuming that we have a number in there always, right? So maybe I shouldn't do this. Let's just use a for loop. For int I equals to 0, I less than 15, I. The problem says we can assume 15, so whatever. We're gonna go digits, index of I, and then we're gonna print f. But we need to print out the dashes though, right? So 1, 2, 3, 4. I'm kind of confused. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 characters long. What song is this? This is terrible. Okay. Hey, what's going on, Kicksurf? Tricksurf. Okay, you store the phone number in its original form or numeric form. Array of characters. No, I don't. Oh, and I can just print it in %d. Okay, so if you print f, digits index I, but what about the hyphen? ASCII chart. $45 is the hyphen? Okay, so if the character So if we have the ASCII character 45, which is the hyphen. So else, so if this, okay, so then I guess we have to have an else, digits, index, I, right, is equal to C. Okay, I think we have to have, C has to be defined, right? Char get char C. Well, char get char C until we reach \n. Else we'll put the digit there into there, and we'll print digits index printf digits index I, and then we'll print this into numeric form. Like so. And then I guess we'll print, and then after this loop, we'll print f \n. Okay, let's try it. Oh no! Whoa. Okay, so we can't do that guy there. So we have to be char C. So we want to do 1-800-collect. Dang. Okay, so we definitely did that wrong. Capital C is 67. Okay, this is garbage then. Okay. So okay, so we're entering a phone number. We're keeping track of an I value to stop at. Well, I guess we don't even need this because they're gonna go up to here. So, but I mean, we'll keep it anyways. So if this, else the digit is just the character. Oh, okay, hold on. So we'll do. Oh, shoot. So you have to print the. Oh, so we'll do. Because if the we're gonna say let me just let's go to here and say print f, and let's do percent d and we'll put in digits index of I here. Let's say vowels here. Okay, let's see what's going on. Okay. Vowels are 49, 45, 56, 48. Oh, so maybe it was printing 45. Yeah, 45 is the hyphen. So it's getting my hyphens correct. It's just printing them in numerical form, because it's converting okay, so if the value is greater than 0, then we're going to print the if the value is less than 0. Okay, that's what we're going to do. So if, we'll say, yeah, if digits index of I is less than 10, then we're going to print just the numerical form. Else, we're going to printf the character form, because we know that values that are going to be greater than 10 will be either the hyphen or, well, no, I don't want to do that. L, that went to 4. Let me make this a integers, 15 places. So if this is equal to quote A is equal to C, or C is equal to B, or C is equal to quote C, right, then we set these to 2. Right? All right, let's keep pushing. So let's take this and we'll kind of bring it down to the other ones. For D, E, and F. G, H, I, J, K, L, M, N, O, P, Q, R. Wasn't these one of these four though? Let me go to old phone keypad pick. Yeah, here we go. W, X, Y, Z is, and there's a 4 on PQRST. PQRS has 4 values. Yeah. PQR or S. And then there's TUV. TUV. And then it goes W. Oh, let me take this one. W, X, Y, L, Z. Okay, so you enter the phone number. If it overflows, it overflows. We are assuming 15 based on what the people say, but I guess they could put in anything they want. So we'll just have that in to be safe. I could use a for loop to, go 15 times strictly, but, they might go short by my interpretation, I guess. It's no more than 15, so it could be less. So if the value that they enter here for this get char is equal to this, we're going to do this. Else we're going to put the character into digits, index I, right? If the character is less than 10, right, we're going to print it as a digit. Else we're going to print it as a character, meaning that we're going to save the hyphen in this else, I think. Okay. We printed out one extra digit at the end. Why? We printed out one extra digit. Oh yeah, because this isn't for... That's what's annoying. So I guess we'll say while... I don't think we should use a for loop here, right? Because this is only... Like, what if we put in 0, 1? It's only 14 characters long. Now this is 15. Right? So that's exactly what I was talking about earlier. So let's do a while. And while what? While digits index of I is equal to, or is not equal to, the null terminator, right? While it's not equal to the null terminator, we're going to do this evaluation here. Something like that. Oh, dang it. Oh yeah. Wah, wah. Dang it. I wonder if that's because we're reusing I here, but we're resetting it back to 0. Does the book give solution? I don't know. I haven't checked. Something to change my mood. Okay, so why are we getting this overflow? Oh, well, because this is 15 digits long, and so it's accessing a garbage value. Mm-hmm. Because the total terminator is it's accessing that value that wasn't actually initialized on index 14. That's what's happening here. That's annoying. Why would they give this problem 15 characters long if the example is only 14? I get that you could probably have 2 digits out front, but maybe I keep a count. I guess that's my only option here. Well, we know what I is, right, at the end of this. Right? I at the end of this is the length of how many iterations we did. So what I can do actually is just say, let's set this to j equals to 0. Then let's say we can change this to a for loop for int j equals to 0, j less than I, j plus plus. Get rid of this. Get rid of this. Now let's try it. Come on. Dang, dude. What? Oh, whoops. J. Boom, 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 boom. Yes! Bang! Boom! 5 big booms. Let's go. 5 big booms. Alright, that's that problem. 11's done. Number 12. We're moving. So many modify the programs. Come on. The author's getting lazy. Modify programming project 5 from chapter 7 so that the Scrabble values of the letters are stored in an array. Okay, this is our project from, remember, project 5 from chapter 7. Where'd you go? Okay, here we go. So what we have is a character and a total 0. Enter a word. We get character. We assign unsigned char C to upper, casting unsigned char to the character that we're receiving of get char. Okay. If it's any of these, you give points. Okay, and then you have total points. Perfect. Okay, that's fine. So this one says, so that Scrabble values of the letters are stored in an array. The array will have 26 elements corresponding to the letters of the alphabet. For example, element 0 in the array will store 1 because the Scrabble value of letter A is 1. So we store a 26 index array corresponding to the scores of the indexes of the alphabet. Okay, that's cool. Whatever. I guess we're going to have to make this ourselves then. So let's do int scores size 26. And we'll set this equal to an array where A is score 0. Let's go back to B is 3, C 3, D 2, E 1, F 4, G 2, H. Where are you? Did I not get H? Oh, it's right there. 4. I why am I so blind? 1 is the vowel. J and then K. 8. 5. L M N 1 3 1 O 1 P 3 Q 10 R 1 S 1 T 1 U 1 and V 4. Yeah, V is 4. Right? Case, yeah, V 4. QRSTUV W X Y and Z. So W 4 X 8 Y 4 Z 10. Okay. Let me run this real quick to make sure that that actually works. I have the correct length. Or let me do this. Print F percent D size of scores over size of scores index of 0. Okay, so let's go here, open this bad boy up, GCZ-0. Ah, no! Oop. Ah, bug is life. Okay, so it's gonna be... Oh, it's a warning but unsigned long. $26. Perfect. Okay. Nice. So that'll print out. That's good. So enter a word. That'll happen. So then what we want to do, if it's in these ones... Okay, so we need to index into the corresponding words. So these are 0 through 26. If they give a character, we to upper that character, and then we need to less 65 from that character to convert it to lowercase to map to 0 through 26. And or we could just get rid of this, or maybe do to lower or something, but whatever. And then what we can do is just delete this in its entirety and do we're gonna do scores index. Oh, we don't have an index here, right? Okay. I guess I'll set I equal to 0 out front, whatever. Oh no, we're not going to do that. We're going to take our character value now, right? And actually use that as an index. So we're going to do scores index of the character. don't think we need to like int cast or everything because it'll still work as a character. It's just an integer. And then we're gonna do total plus equals to this. I think we're gonna run that. Scrabble. $13. Let's make sure. Hold on. Let's do an easier word. Easier word. Let's do Mike. So this should be. Oh shoot. Well, vowel, vowel. So 1 and 1. K is a 4, I think. And M is a 3. Maybe M's a 4 as well. That would make sense. 4, 4, 2, 2. I think it's working. Let's go open up that other one and see real quick. Make sure that math's right. Chapter 7, exercise, or programming project number 5, Scrabble. M is a 3. K is a 5, that's why. So 8 and then the 1 and the 1. Perfect. All right, that's that. Let's get caught up on some chats. Make it char digit 16 question mark. Oh, you're probably maybe referring to the last problem. What's my favorite language? Oh, I don't really have one. I don't really know enough to make that say. So, I mean, Python and C are pretty similar in style. It's just, it's not very different. There's just little nuances here and there that are different function calls, different ways of looping and stuff, but it's very similar to the overall process. And I think I'm starting to understand just the overall, like, similarities of just programming language in general, right? Okay, cool. Number 13. Man, there's a lot of projects in this chapter. Let's turn this song up. This one's so good. Let's jam out, boys. I'm gonna restart this one. Been day to day, been rough. Oh, tough, my bad. Been tough. Sorry. At my side. Been rough. There's the rough. Is that way? I'm not trying to forget her. And I'm not feeling that day. Just like seeing her. Come on, what do you guys know about this one? For the first time again. This is one of those songs you just like sit on your bed and look at the ceiling fan, just go around and around with your cord headphones in, just looking at it. It's one of those vibes. Alright, here we go. Number 13. Mac the Goat. Modify programming project 11 from chapter 7 so that the program labels its output. Enter a first and last name. You entered last name, then first letter. The program will need to store the last name but not the first name in an array of characters until it can be printed. And assume that the last name is no more than 20 characters long. Okay. Programming project number 11 from chapter 7. At least these ones aren't too tough, right? Hopefully. Okay, so enter first name and last name, and we say get char. So we're going to say char letters, right? We'll say last name which is an array of size 20, right? Enter first name and last name. While get char is not equal to a space. Enter first name and last name. Why do I have this? While C equals get char. Oh, I see the first name, first letter here. Oh, I extract that out. Got you. And then I go until the space. Perfect. And then I get out the last name here. Okay, so then we're going to go here and go last name. We'll say int I is equal to 0. Last name index of I is equal to C. And we'll say I plus plus here. And then that'll save the values of the last name in the array. We're then going to say, for int j equals to 0, j less than 20, or j less than I, right, like we did before, j plus plus, open that up, because I will save, this I value will save the length, basically, of the last name, so we know exactly how many to loop over dynamically. So we're going to loop over last name index of I, and what we're going to do is print this. So print f, we'll do a %c, last name, index of I, and then we're going to print a comma, space, %c, and we're going to insert into here first name, first letter. And then that will handle that, I think. And then period. And then we're going to return 0. All right, let's try this one. GCC-O. Boom. No bugs. Let's go. First name and last name, Michael Deming. No. Why? Why? Enter last name, first name, last name, get char, we'll get the first letter. While C equals get char is not equal to a space, we're going to continue going until we hit the space. C is equal to a space. Now we're going to say while C equals get char, C gets char of the last name, first letter. We save that in last name. Index of I is equal to C. Let me print FC here and see if that's working. What the heck? Did I run the wrong program earlier? Oh, J. Boom! There we go. Thanks, Beetle. I appreciate you. Yeah, we had to use I here to basically I carried our length value for us of the last name, so we didn't need to actually compute any, what, by having like a buffer limit that might not be filled all the way. We don't have to compute whether it's the garbage value or whatever. We can automatically just count how many characters are used, have it I be our length counter, and then use that to compare against an iteration over a loop. And then use J as a new value. Yeah, exactly. Cool. Let's roll. That was a good one. Oh yeah, I got you. I put the continue just visually. I like to because I read it. I like to read it, and for other people that are newer to read it too. But yeah, you could just void it out and whatever, and it'll just continue through the loop. Because I had a copy of this program from before, so having that, cause we did this back in the past, so having those statements kind of helps sometimes. But yeah. All right, cool. Thanks, Beetle. All right, we are moving right along. We got four more. We've been going for an hour and a half. It's 8:55. Oh, okay. Dang it. Four more. This one has a lot of problems. Oh, who was that? Hey, Beetle. Thanks for the follow, dude. Hey, no, literally A, not A. A. Thanks for the subscribe on YouTube. Tanuj, thanks for the subscribe on YouTube. I appreciate you so much, Tanuj Shamil. Thank you. That was an hour ago. Sorry, I missed that. AUCKT. AUKCT has subscribed. Thanks so much, dude. Appreciate you for being here. If you guys are new, my name's Michael. I'm 26 years old. I got a degree in human bio, minor chemistry. I'm about to actually turn 27 in a couple of days, in about 2 weeks. Which is kind of wild, y'all. Wild. 27. Oh boy. I really appreciate everybody being here. I got a degree in human bio and a minor in chemistry. Been teaching myself how to code first off in in Python, and now we've been transitioned into C and understanding what's actually going beyond Python and what's going on underneath the hood in Python. I wanted to really understand, truly what I was writing in Python, so we started learning C, which has actually made Python learning a lot kind of more intuitive as I've been able to really understand some of these functions more. We're doing C Programming, A Modern Approach, second edition. I have been reading through the book live on the stream here and uploading audiobooks to the channel. If you want to check that out and listen along to the chapters, they're awesome to get some good review and introduction to C. And then we complete the problems at the end here. So we're on chapter 8, about to wrap it up. On problem 14 here. So this one's been quite extensive, as you can see. A lot of problems for this chapter. So maybe we'll do one more here. Write a program that reverses the words in a sentence. Easy. Okay. We're going to include the standard io.h header file, int main void. Okay, that's gonna bug me. Okay, so what we want to do is we're gonna have char letters. Ooh, hold on. And this is going to be undefined size. Well, we have to allocate space, right? So let me look up really quickly. Do you have to allocate a size for array in C to put stuff in? I would assume. Okay. Oh. Okay. This is what we'll do. While we'll do char c, while c equals to get char, and that does not equal to the \n, right? We're going to have an I variable, and then we're all going to do this. We're going to wait, what? Reversal of a sentence. Oh, this is like reversing. You can. You want to reverse words. Oh. Oh, I thought this was just straight reversing letters. My bad, my bad. Um, okay. Um, okay, so we can just store all the characters, loop in reverse. Oh, yeah, it is all the characters in reverse. This is why. No, but it's the words though. It's not the individual. Oh, got you. So you can't just go and print the ith character in reverse, like the -1 or whatever in Python, because you're trying to extract out the whole word. We're not going UOY T apostrophe NAC. We're not doing that. We're doing whole words. So use a loop to read the characters one by one and store them in a one-dimensional char array. Have the loop stop at a period question mark exclamation point, which is saved in a separate char variable. Then use a second loop to search backward through the array from the beginning of the last word. Print the last word. Then use a second loop to search backward through the array from the beginning of the last word. Print the last word, then search backward for the next last word. If you loop backward through the array, right, if you loop backward through the array, how could you print each word? We might have to come back to this one tomorrow. We're running out of time here. It's already 9. We've been going for an hour 40. So I was thinking we use a two-dimensional array. What if we use a two-dimensional array where each inner array is a word? Well, the thing is, so you make each character in your sentence a index in your array, but then when you loop backwards, how do you print out the word going forwards? until you reach up here. Oh, you see, until you reach probably a space or the delimiting character or the end of the array with an inner loop. To search backward through the array for the beginning of the last word. Print the last word. Huh. So if we go letters is an array of characters. And we say this is like a size, let's say like 100. Or no, let's say like 50. Okay, we're gonna say letters index of I is equal to the character, and then we're gonna have I plus plus we can do plus plus after that. And then hey, what's going on? Bastola, welcome. Welcome back in, dude. So we'll save that in the array. Okay, and then we say, let's just do this for int I. Variable get charge equal to this. So we'll see that is that value. So then we'll do or C is not equal to quote question mark or period. Period. So we'll do that. We'll keep going. And then let's see if we can actually print out the sentence is working. Okay, let's see here. What do we have to do here? It's interesting. Oh, we have to have a prompt. Oh, hold on. Okay, that didn't work. So while okay, we'll just do the normal. While it's not equal to the backslash n, right? And we're gonna have if c is equal to quote question mark, or c is equal to quote exclamation point, or c is equal to quote period, right? Then we're gonna save punctuation equal to c, which are punctuation and then else we'll go forward like this. All right. And then I guess we'll say I plus plus here just to always move I forward. Okay. And then we're gonna print f to the punctuation. And then what we're gonna also do is we're gonna loop backwards. So while j is equal to I, while j is greater than or equal to 0, j less. If letters index of j is equal to a space, then what we're going to do is loop for int n int k less than, and I will say we'll say this, we'll say while letters index of so if it's equal to a space, we now need to print going forward, right, until we hit a space or the end of the array. So we're going to say while, I guess we'll keep going, and we'll say if the oh no, so we need to say k is equal to j at this point. So j is on a space right now, meaning that we've gone to the space. So j plus plus, that's j plus 1. So k is equal to j plus 1 to move us forward 1. And then we're going to print while 1 if letters index of k is equal to a space, then we're going to break. Else we're going to print, I guess we don't need it, so we're going to print f and do %c and do letters index of k plus plus. So what's happening here is we're looping backwards through the sentence array letters. If letters that we're on as we're looping backwards ever meets a space, right, we're knowing that we need to stop here, move back one forward as k is equal to j plus 1, right, because j is moving downward, so we got to move forward 1 to this y and go until we hit a space or up until the end of the array. So while so I'll say this: while letters index I does not equal to a space, we're going to continue and do this, right? Let's see what happens. Int k. Michael Deming is live. Dang it. Where am I from? I'm in the United States, California right now. So we're looping backwards. I guess we'll just say for, what if we say k is equal to j plus 1 and length, we know that I is the total length, right? So we'll just say for k I'll just take this, put this here. Okay, for int k equals j plus 1, while k is less than I, which is the full length of the array, you know, we're going to go k plus plus, and then what we're going to say here is we're going to say do you think it's way better to learn relying on tutorial because it takes practice understanding, or doing while learning? Cursed text, it says evil. Yeah, I saw that. Depending on the other code, you can pass the more Python, I guess. Yeah, we're doing C right now. I'm also learning C. I've been trying to understand how to pass a pointer to a function. It's a bit confusing. Yeah, that part's a little bit confusing. Our pointers, I think, are on our next chapter, so make sure you be here when we're about to wrap up this one, probably tomorrow. Tomorrow will be our last time on chapter 8. So for doesn't this line up to anything? Okay. So we're going to say if okay, let's try this. Oh, we're close. And then after this loop, we're going to print f a space, right? This one's tough. This one's tough because we're having to loop backwards and print words rather than each letter, right? And we're not reversing the sentence. We're reversing the sentence by word, not by letters. So I'm having to stop once I reach a space and then print the whole word. Right? My brain's getting fuzzy here. I'm going to get a little bit of feedback on this one. I'm going to get a little feedback on this one. We're close, but not quite there. We haven't gotten any feedback yet tonight, so I don't feel bad getting a little bit of feedback here. Let's get a little feedback. Little feedback. Can I get a little feedback on my fail of a program? I am reversing a sentence for a word, not the letters, but the words. I tried to loop until I saw spaces and loop, going backward, and then go forward to print the word, but looking dicey. Actually, very close. Your instinct to scan backwards for spaces, then print forward to omit each word is exactly the right mental model. The issue is mostly indexing discipline and state tracking and logic, not logic failure. You separated punctuation from content. That's good design thinking. You're preserving the punctuation repenning at the end. You stored the sentence in a buffer. You attempted a backward scan to find word boundaries. So I is incremented even when the punctuation is skipped. Oh, okay. And we don't want to. Okay, got you. So. Interesting. So. Else letters. We don't increment I when the punctuation is skipped because we want to stop one shy of the punctuation and not include that in our length so we don't get that extra space, I think, right? Something like that. Well, I guess we'd be doing backwards one extra, and that's probably, maybe do negative indexing. Yeah, none that later gets read. That's probably why we're getting garbage values in some of them. So is equal to I less than 1. Still's doing it. So the first word, that's why we're not getting the first word because it has no leading space. Got you. So once we reach the end of the array, we need to go forward. So if I is equal to 0, so is equal to if j is equal to 0 or letters index j is equal to that. So that will print out the first letter or the first word. But we're not getting, because k is going to j plus 1. Ah, interesting. Let's not print the space here. Let's print this space. So we're going to be on the space. We're going to print inside space. So let me say this. Do, right, we're going to do print f %c and we're going to insert into here letters index of j, right? Print out letter index j. And then we'll open this out. So we'll do a print on the space. We're going to then if we want to move J up in advance right here. Well, I don't think we want to use J actually, because we probably want to use a variable of so if we're on the first index or the first word or the space, we're going to print out the space or that first letter. But I need to move, but I don't want to manipulate J because J is going backwards. So I need to save a new value, int K equals to J, right? I'm going to put K here, and then move K forward right here, so that when we do the while check, right? When we do the while check, while K is not equal to a space. So now that K gets moved forward, if K is equal to a space on the next character, we won't print again. Expected do something while something. Is it do? How do you write a do while? I forgot. Do. Oh. My bad. Do this. Right. Okay, so let's take what we have so far here, get some feedback on this one. You only increment when I shows the counter. You start reversing at I less than 1. You handle the J equals 0. Run until K equals to 32, or run off the end of your array, or print garbage. Character at K is the space when it reaches the end. So the first character you print is a space. You want to start printing at each space, set start, print forward until space or end of input. Okay, so let's do I guess let me go back to what I had previously with the for loop. So for now this though isn't right, because I get the okay, there we go. But then I don't want to print the space So we'll say here, okay, we're gonna print a space here, right? So this will be where space goes. Let's test that. Right? We're not getting the first character. Because it's going to j plus 1 when I is equal to 0. If we just print this space. So let's print the value of j and print this space. We won't need to print this space because we'll actually print the space. Let's print. We're going to do the print. If letters k plus 1 is equal to a space, well, we probably would need to go less than 1. So I has to go less than 1 if we're going to evaluate k plus 1 here for the space on the previous iteration. So if k else, we're going to print k plus 1. So it's printing that space beforehand, right? Okay, so maybe not. We don't want to print that space. We'll print the space here. But right, it's going to pass over j plus 1, right? It's going to pass over. Because it's going to pass over the space unless we do j plus 1 here. So now it'll pass over the space on the first one, it'll print until we hit another space there. Right, so now we're getting this. Right, but we're just missing the first letter and we're getting a space afterwards because of this. So if j is equal to I less than 1, no, if j is equal to 0, we're going to just print the value that we're on. Okay, so let's take this, let's say I am close, but missing the first char because of the j plus 1 for rendering words, and the space trailing in the loop post word print causes a space in between the punctuation, right? You said it yourself, missing the first character by the J+1. I have two cases, but I'm treating them as one. Okay, so I need to separate. If J is equal to 0, then do this. If it's equal to a space, then do that. So if J is equal to so we'll have to do the 0 first. We'll copy this. Open this up. Do that there. Get rid of this. So J is equal to 0. We're going to do this for loop. Else if J is equal to quote space, then we're going to do this. Right? So that'll handle the first character. Ugh. Okay, so then now we're getting, so this has to be just equal to J. This is J+1 if it's equal to a space. But that's not working with the we had before. Huh. Best way to learn to code is coding, not watching tutorials. What's your end goal in CS, by the way? Just learning for fun. Gaining new skills. Okay, so we're getting Michael here. So for this is looping backwards through I. Once J is equal to 0, we're only going to print if J is equal to 0, else if J is equal to a space. if j is equal to a space, we're going to go forward one and print letters until we don't hit one. So why is this else if... I'm getting tired here, you guys. I gotta get out of here. It's almost 10 o'clock. So we're only printing if j is 0 when we hit the end, or if it's here. So this one's not working here. Oh, j is not as space. It's letters index j. Right, if letters index j is equal to the space. Yes! Yes, yes, yes! Let's go! That's what I'm talking about! Let's go. Alright. Look at us working our way through it. Grinding our way through it. Yes! Okay, that one was tough. That one was probably one of the harder ones of the chapter, honestly. But I feel really proud that we were able to actually get through that in under like 15 minutes. Maybe a little longer than that. Okay, so what we had to do there is we were given this goal of reversing a sentence based on the words, not the letters of each word. So we're not reversing just the letters in a sentence. We're reversing the words. You can cage a swallow, can't you? You can't swallow a cage, can you, right? All of these words got inverted to the end versus the front of the sentence, right? So the thing is we needed to gather all the letters into a char array. We haven't learned about char star arrays yet, even though in our personal project we did start using pointers and stuff. We started kind of jumping the gun in our project we started writing a couple of days ago. But next chapter we're going to really hammer home on pointers, I think, right? Which is going to be awesome. So what we do is we have a char C and a punctuation. This is going to be where we're going to be getting our characters from the input, and this is going to be saving the punctuation in. Then we're going to have our buffer of letters for the sentence. I just have 50 here for just 50. I mean, I'm not sure how long your sentence is. It's kind of arbitrary, whatever. Then we have a counter here, right, for the length. I will be basically our length of the array, of the entire sentence as we count up through inputs. So we count up through inputs, and we don't count the input of the exclamation point. That being said, is we loop for all of the actual characters we want to print out, which is not excluding the exclamation point, right? We're looping over letters. We're looping backwards. If we ever reach a point where the letter is a space, we know we've reached a point where we passed a word, right? If you think about it, in how sentences, you have a space and then a word, a space and then a word, followed by maybe some punctuation. But there's always a space in between words. So we can use that as our delimiter and say, okay, we've met a space as we've gone backwards through the array. So now we know we need to actually go forward until we hit another space to print and render that word we went backward over, basically, right? So here's our sentence, Michael Deming is live. We started out here, we went E, V, I, L, space, else if letters index J is space, it is, we're going to set K equal to J plus 1, which is the L, right? Which is the L. And then we're going to go forward until the end of the array until we reach another space or the end, right? Because we could hit another space if this is a word in the middle, like we hit the space here, we go J plus 1, which is K, go until we hit a space, boom, we render that out. Or we go until we hit the end, which is like the last word. And so in the case of the first letter, right, we have to not go j plus 1 because we don't want to move to the I and actually not print out the M. We want to have k just be equal to j in this one. And so we'll just actually print the letter we're on. Now there might be a little bit better way to optimize it with the way you print the space, whether you might be able to print it before and then change a little bit of logic, and you might clean it up a little bit, but whatever. Oh. I visualize the alg in my mind. That problem is still a good one. W. What's up? Great. You follow me on YouTube? Nice, dude. Welcome. Appreciate you for joining me here and finding me on Twitch, man. Welcome. All right, I'm done for tonight, boys. Sounds good. Got the job done. Solved the problems. Bada bing, bada boom. All right, we're going to finish the chapter next time. So this was C Programming, a Modern Approach, 2nd edition, chapter 8. We're almost done with chapter 8. We finished problems 11 or 10 through 14 today. It took us 2.5 hours to do these 5 problems because they're pretty lengthy. We're having to go back through and modify previous projects from other chapters and make them into arrays and stuff. So I had to go through and kind of learn remember what we did and change stuff over. So tomorrow we'll tackle 15 through 17 and we'll be done. Oh yes, we'll be done. So we'll do 15 through 17 tomorrow, and then maybe if I'm feeling it, 9's functions. I thought 9 was pointers. Dang. 9 is functions. How long is chapter 9? Let's see. How long would it take us to read? 183 to... Oh boy. Oh boy. Oh boy. Oh boy. Oh boy. End of questions is here at 2:14. Oh, it's long. It's like 30 pages long. Bro. Oh, that might be a two-parter, boys. That might be a two-parter. I don't know if we can do that in one go. Yeah, that might be it. I might have to break that one up. All right, you guys. Thanks so much for being here and hanging out with me. We are. I'll before I go, I mentioned. So the problems that we did, we are bound by what we've learned in the book so far. Yes, there's stuff we've learned in C through CS50 and in Python and other stuff that we've kind of learned about before that we could use to solve some of these problems a little bit easier. But we're really trying to solve them with the topics that were introduced in the chapter and only in that chapter and past chapters. So we really know to utilize what actual functionality is needed to compute stuff. More data structures and things makes things easier, but if we understand the scope of what what a simple function or concept can do in its entirety, we can really understand it even more, I think. So I like it doing it this way. I think it's fun. I don't really care that it takes us a little while to do, and it takes us hours to do these problems on stream. I'm learning and having fun, and we're not trying to get a job in it. We're just having fun learning. We already have a job. So I'll see you guys tomorrow. Thanks so much for being here. Make sure you subscribe if you want to join me tomorrow. I got a link down below for my description for my Discord, which has basically a collection of all of my resources that I've used to learn in programming. Every book kind of link, program, projects I've done, more offline stuff. So if you want to be part of the community, join the Discord. I throw a couple of stock pointers in there as well. We've been pretty successful on the stock market. So I'll see you guys tomorrow. Thank you guys so much for being here. Peace out.